Okay, in this lesson, we're going to talk about applying quadratic methods to help us solve nonlinear systems. So you guys haven't done system of equations for a little while, so I'm going to kind of refresh you on linear systems and we'll apply those to nonlinear. But first of all, let's talk a little bit about what it means to solve an equation. So we understand what our solutions should look like. So in this first one, again, it asks that question, what does it mean to solve an equation, right? So solving means that we have some sort of relationship set up in an equation and we want to determine the values that make the equation true, right? So we could start at an elementary level and say, well, 3 plus something is equal to 5. The only value that we could plug in right there that would actually work with our equation would be the value 2. 3 plus 2 is equal to 5. Now, that is the value that works to make the equation true, right? We solved that. Now, because techniques for solving and understanding relationships and equations get a little more complicated, we use variables to represent that. So the equation could look something like 3 plus x equals 5. We use the variable to represent that. This is what we call a one-variable equation because there's only one type of variable involved here. There's only one value that's going to work to solve that equation, right? And we know that x is equal to 2. That's the solution that works for that equation. Solutions are distinct values in a one-variable equation, right? We could find them on the real number line for that type of one-variable equation. So a two-variable equation, what I want you guys to understand is that a two-variable equation looks something like this. It might say 2x plus 1 is equal to y. Now, if I'm looking to solve this one, x and y, they vary in relation to each other. So if I plug a certain value in for x, that actually determines what the output value is for y, right? We create these what we call functions. So for example, if I say, well, what if x is 2? Well, 2 times 2 plus 1, right, is 4 plus 1, or in other words, is 5. So it comes out as like an ordered pair. We're saying when x was 2, then the y was the 5 value. So we can write these as ordered pairs, and these are what we call, again, two-variable equations. Their solutions, they come as ordered pairs. And it makes sense if you think about it as a graph. If I have my linear graph here and I was graphing the line 2x plus 1, there's my y-intercept, so I know it's going to cross at positive 1. It has a slope of 2, so I would go up 2 over 1. There's 1. Oh, that's a terrible graph. Or I go down 2 over 1, right, and I can draw another line, and here's my linear function there, 2x plus 1. This point that we just found, 2, 5, would lie on this line, over 2 and up 5. All of these points on this line are solutions, or they're pairs of x and y values that would work to satisfy this equation. So when we talk about solving a system of equations, generally we're finding, again, ordered pairs. We're dealing with two variables and we're talking about what values are going to work to satisfy not only one equation, but now we're looking at what we call a system. And so a system, right, is going to be more than one equations. And we want to find the intersection or the solution that is common to both. Okay, and I say both because we're going to do two equations in our systems, but you can have more than that. So we could say to all equations, right, of our system. So let's just go on a refresher and talk about what you've learned in the past related to this. So first of all, if they're linear functions, we can have different types of solutions. So let's say this is my x and y axis here, and I have a line headed increasing to the right, and let's say I have another one coming this direction, decreasing to the right. Notice they have one intersection. That point right there is their solution. That's what's common to both of them. So this system would have one real solution, and again we would write it as like an ordered pair. Whatever that point is, x, y, that would represent the solution to that system. You could also have parallel lines. So I'm not sure if my lines will look parallel, but if these are parallel, let's put this little symbol on it, means they're parallel. Those will never cross. So because there are 0 intersections, we would say that there are no real solutions, or we're just going to say no solutions on this one. They're never going to intersect, so we won't have a solution there. And then the last kind that hopefully we remember dealing with are the ones where you had a line, and then you had another line, and if you were to graph both of those, they actually were the same line. They were right on top of each other. In that case, right, we said, well, there are infinitely many solutions because they share every point. So every point on this line is a solution. So those were the 3 conditions that we saw. And the way that we solved for those was we either graphed them to find the intersections and that relationship between those two in the system, or we used elimination or substitution. So let's talk about these 2 methods, and then we'll talk about if we have nonlinear. So elimination, remember, the goal with elimination was to eliminate one of the variables. Because we have an equation with 2 variables, we can't solve for just one of them and actually find a specific solution. So instead, we take these 2 equations and we add them together to eliminate one of the variables. So notice right now, if I were to add these equations, just top to bottom, I'm going to combine like terms, I would get 4x. 5y minus y is plus 4y equals 11 minus 1, which is 10. That didn't eliminate anything. So if you remember, we had to come up with a strategy to allow us to eliminate. So these are both 2x's. If one of them was negative, and then I add 2x minus 2x, that would give me 0. That would eliminate this variable. So that's essentially what we want to do. And it's fair game to go ahead and multiply that bottom equation by, say, a -1. So a -1 would change all the signs there. Then I can go ahead and add these. So 2x minus 2x, that's just 0. 5y plus another 1y, that would be 6y. And now we have 11 plus 1, which is 12. So if I go ahead and solve this now, because all I have is a y variable, I just divide by 6, and y is equal to 2. Okay. Now remember, in our solution, or in other words, the point where they intersect, we're saying that y is equal to 2. You still need to find the x value to represent the full solution. So to find the x value, you just take your y value and you plug it into either equation. So if we come up here, let's say we just plug it into that original equation, 2x plus 5, and then remember, you just found the y value of 2, so we substitute that in, is equal to 11. We can simplify this. 2x plus 5 times 2 is 10. Subtract the 10 over, and 2x is equal to 1. Divide by 2, and x is equal to 1/2. So in this case, your solution there is the point 1/2, comma 2. Okay. Now, substitution, your goal was really to solve for one of the variables and substitute it into the other equation. So let me show you here. On this one, y doesn't really have a coefficient, so I'm going to actually solve for that y. So again, if I take 2x minus y equals -1, and I subtract the 2x over to the other side, I'm trying to solve for y, I get -y is equal to -2x minus 1. I don't like the y being negative in this case, so I'm just going to multiply everything by -1. So it changes the sign of all of those. Now notice you've just solved for y. So you know that y is equal to, or has the relationship of 2x plus 1. So if you can take this now and plug it into the other equation, or what we call substitute it in for y. So notice if I take that original equation, I would have 2x plus 5, and then I need my y value there. And again, we decided y was 2x plus 1, so I'm going to put 2x plus 1 in there. And then finishing that out, it equals 11. Notice when you use substitution, again, you've created an equation with one variable that you know how to solve for. So we can go ahead and distribute this 5. We get 2x plus 10x plus 5 equals 11. Combine our x terms, we get 12x. Let's subtract that 5 to the other side, and we end up with 6. We divide by 12, and x is equal to 6 over 12, or in other words, 1/2. So again, our solution, we know, and this time we found the x value is 1/2, and we can go ahead and find the y value there. So in this case, we have y is equal to, And let's just take this equation that we solved already for the y, and we know that it's going to be 2 times x plus 1, and you just found your x value, which was 1/2. So 2 times 1/2 is 1, plus 1. Our y value there is going to be 2. So there's our solution. Now notice these were the same systems, right? These equations, if you look at our original systems, are exactly the same. I just went through and solved them in different methods. So what if we have nonlinear? Let's talk about it. Again, you can graph them and find intersections. Now, their solutions might look a little bit different because nonlinear means we can have quadratics, we can have parabolas. So let's say I have a parabola as part of my system in each of these. And it doesn't matter if the parabola is going up or down, either way. So a couple of things that can happen. First of all, the line can just pass right through. So if we have a linear equation, passes through twice, there's a solution and there's a solution. This one can have 2 different solution points. Okay, so that means when we solve, we might get 2 x values and we need to find their associated y values. You could also have a line that just touches. So let's say it just touches the parabola. This would have just 1 solution point. So as you're solving this one, you're going to come up with 1 x and y value that works. And then lastly, it may be that the line never actually crosses, in which case you're going to state that there's no solution to the system. Okay, so jumping down, let's see if we can apply these same methods. So we have elimination and substitution. So elimination, again, you're going to go ahead and add the equations together, trying to eliminate one of the variables. Notice right now, if I were to add these equations together, y plus y would be 2y, and then I'm going to have a lot of x terms over here because not everything or nothing is going to eliminate. So the goal with this one is you really want to negate one of the y values. So if I have a positive y on top, maybe I'm going to multiply this bottom equation by a negative. And when you do that, I'm going to rewrite it just over here so we can see it. The top one we didn't change at all. The one on the bottom, we just multiplied by a -1, so that became negative y. And I'm going to line up this term with its like terms, so negative x, right, and plus 3. And I just lined it up with the like terms, so now when I add this, again, y minus y is 0. So we get 0 is equal to, that 2x squared doesn't combine with anything, so it just comes down. 5x minus x is 4x, and -1 plus 3 is a positive 2. Now we have a quadratic equation with just x variables that we can solve for. So again, factoring is the fastest method, so I'm going to look for factoring first. It looks like everything divides by 2, so I'm going to divide a 2 out of everything. We get 0 is equal to x squared plus 2x plus 1. Then we continue to factor that. So we split this up, x and x, everything's positive, and 1 times 1 is going to work for that. So if we look for the solution here, it looks like x is equal to -1 or x is equal to -1. Now if it's a repeated solution, that's one of those where there's just one solution point, right? There's one x value that came out that works. So when I find, or when I'm done and I find my solution, I guess I don't need to write solutions, I know the x value is -1, so now we just need to find its y value. Again, you just plug the x in. It's easiest to plug it into the original linear equation. So if our original linear equation was y is equal to x minus 3, so we know that this is going to be -1 because that was the x value we found, which is going to give us -4. So the y value is -4 when x is -1. Okay, so elimination works very good when they're both solved for y. You just make one of the equations negative, or change the sign by multiplying by -1 and then add the equations. Substitution's very similar because these equations are already solved for y. Essentially, all you're doing is taking this and you're plugging it in for the y. Another thing to think about is if they're both equal to y, then they're both equal to each other. That's essentially what you're doing. So you're taking this, putting it in for y, or in other words, we take 2x minus 1 is equal to x squared plus 2x minus 5. That just created a quadratic equation again with one variable. So we know how to solve this. We need to set it equal to 0. So let's move all the terms to one side. We'll subtract 2x. We'll add the 1 over. And when we do that, we end up with x squared. It looks like our middle term adds to 0, and then we get minus 4. Notice there's no b term there, so I can actually solve with square roots. So I'm going to use that one. I'm going to add the 4 over. We get 4 is equal to x squared. Remember, to undo the squared, we use square roots. So we square root this side to get rid of the squared. Square root this side, which introduces that plus or minus. And the square root of 4 is 2. So we know that x is a positive 2 or a negative 2. So this is one of those where it has two x values. So there's going to be two solutions. One of them, the x value is positive 2. The other one, the x value is going to be a negative 2. And then you just need to find each of their associated y values. So again, I'm going to take this original y equals equation, and I'm just going to plug in each of those values. So y is equal to 2. Let's do the positive 2 first. So we let x be positive 2, which would be 4 minus 1, which is 3. So we know that when x is positive 2, the y value is 3. And then we do the negative 2. So when x is negative 2, the y value ends up being, it looks like, negative 5. Okay, those would be your two solutions. So on your assignment today, you're going to practice with each of these methods. If you turn over to the next page, there's some more examples in your guided notes book if you're using the guided notes book, or you're welcome to kind of just look back at the ones that you have. Again, maybe it's not on the next page. So there are more examples that we could try, but again, just remember when you solve a system by graphing, you're going to plug these equations into a calculator. So if you're using the TI-84 calculator, you would go to your y equals. One of them will go in like y1, and one of them will go in y2, and then we figure out where they intersect. I'm going to walk through those steps really quickly. You're welcome to use either Desmos or the calculator. So if you have your own calculator, let's talk about that one first. Again, you're going to go to y equals and you're going to plug the equations in. So I'm going to do the two equations that you just saw. So the first one was 3x minus 15. The next equation in this system was 1/2 x squared minus 2x minus 7, and we can graph that. Notice here there's two intersections, so where that red and blue line are meeting, they're in the middle of the screen and up on the upper right hand side. You can trace, there's that button that says trace here near the graph button, and it'll move your cursor around, so you can kind of guesstimate where that would be. Or if you would like to use the calculate menu, the calculate button is the same as the trace button. Notice above trace it says CALC, that's calculate. In order to access the blue word, remember you push the blue button first. So we push second, trace, and it takes us to a calculate menu. We can calculate the intersection. So if you push number 5, on your TI-84s, it will then ask you to identify the first and second curve. Basically, you're just going to push enter, 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 and then it identifies the intersection for you, so you can identify that. Okay. Another way where you guys are working at home, if you're online, go ahead and just use Desmos. So if you go to Desmos, and I should have pulled this up already, but again, let me show you really quick where it is on your home screen. So I have to come at it from my teacher account, but we'll find it. If we're looking at this, so if we're looking in student view, you would click on the class. At the bottom of the home page, there is the online graphing calculator link that says desmos.com. So you would click on that. In Desmos, you're able to plug in those same systems. So we could plug in y is equal to 3x minus 15. There's our first line. We can plug in the second one, which would be y is equal to 1/2 x squared minus 2x minus 7. With Desmos, it's pretty easy to see intersections. You just highlight and actually click on it. It'll say 2, -9, so there's one solution, and then there's one up there as well, the 8, 9. So Desmos is really quick in allowing you to solve by graphing. So just be aware on your assignment. Again, you're going to find your assignment by going in here and clicking on 4.5b, Nonlinear Systems of Equations. It will ask you which method to use, and it will ask you to be sure that you show your work. So make sure that I can tell where you're coming from on the work that you're doing. If it asks you to draw a graph, just draw a rough sketch of what the graph would look like, right? There was a parabola coming through here and the line that came through here, and there's the two intersections, and then you would state the two solutions. So the two solutions that we found for this one, when we graphed them, was the 0.2, -9, and the 0.8, 9. So those were our two solutions there. And then again, you'll be asked to use elimination and substitution, so just be sure that your work is shown for applying each of those methods.